This is Brian from Projects in the Bottom Drawer, wearable.com/projects or bottomdrawerprojects.com. This video is probably not going to be for most people. There's not going to be any repairs done or anything really interesting that happens here. So if you're watching this and you're not interested in just seeing someone put some parts on a proto board, maybe talk a little bit about it for the person that this is for, feel free to click off and find one of the other videos that I have that you might like. There are quite a few. But if you want to see someone sitting here just messing around with crap on a proto board, no real goal in mind, feel free to stick around. This video will probably be released out of band of the other one since it's not really part of any series. And this is just a 555 timer circuit. A person has a device that has multiple modes and he wants them to switch about every 20 seconds or so. It has two sides, and he would like for each side to switch at somewhat different times so they're not synchronized. So I'm going to try and build this two different sides, and then we're going to have to put it on a proto board somehow. I'm not sure how that's going to happen yet. We'll find out while we using 100 microfarad capacitors for everything, including the 5-volt regulator, filtering, and bypass. I tried this before. I screwed something up and destroyed the chip. So this is try number 2. Not sure what I did to the other one, but yeah, whatever. So for the first section, we're going to use a 220 and a 22. Hopefully I have those. These all look like 3 somethings. All right. It's a 15. Okay, so there's 22s and 220s in here. And then on the second side, we'll use a 270 and a 220, or a 22. Do I have 270s in here? I do not. I'll have to go to the half-watt bin for that. Okay, it's not in that pack. It's 330, 15, 68s. So if you're still watching, and you're not the person that I'm building this for, What's next on the bench of projects here? Of course, I have, and what did I do with it? I have this guy, this little radio kit that I've been wanting to build. Not sure if I'm going to build that next, or if I'm going to. That might be a rainy fall afternoon project. But there's a couple of Heathkit oscilloscopes. I have a ICO 242 FET voltmeter, which is the cousin of the 249 that I just redid. 22000, okay, 22K. Now let's see what else is over there. There's a Zenith radio, and a couple of Precise 9071s. I thought I was going to just rebuild one and use the other one as a donor, but I might just rebuild both of them because they're actually both in decent enough shape. And I've seen a couple of things on eBay that look very interesting, including an unusual ICO meter that I've not seen an example of before. It's in okay shape. The guy wants way too much for it, of course, the eBay tax. And there's still a couple of Hamfests coming up. Not sure when this video will release, but this is getting toward the end of August 2026. There is, let's see, Johnstown Swappers Day, which isn't really a Hamfest, but sometimes stuff shows up there. There is the Clearfield Hamfest, the Cleveland Hamfest. Those happen in the middle and the end of September, respectively. There's a couple more in there that I usually go to, but because they've been rather disappointing these last few years, I might skip those for the time being. I might skip it for this year anyway. Just to kind of let things. I know it's not the best way to keep your show going, but it gets to a point when it just isn't. When it's just too much of a drive to get there. And you just don't see anything because it's just generally fading away. I mean, whether or not, I don't know if that's because, the vendors are getting old and they're just not showing up. Or if other things are happening, there's so many of them here in Ohio. That, other people, they might just be going to other ones. Who knows? All right, so I've just connected R1. That goes between discharge, which is on the 556 pin 1 to rail, positive rail. Yep, pin 1 to positive rail. So now I'll connect R2, which goes from discharge to trigger, pin 6. I need the 220. I put the wrong one in there. That's the opposite one. Come on, go in there. The problem with these proto boards sometimes is these little pins just don't have enough strength to want to go down in there, and I don't know why. Here, there we go. There we go. So now this one goes from discharge to trigger, which is 2 to 6, or 1 to 6 rather. And of course the capacitor also comes off. Yeah, the capacitor also comes off as 6. Actually, let's do this instead. So we go from 2 to 6. Let's trim this off. Mm-hmm. Come on, go down into the hole. There we go. All right. Pin 2 to 6. That's the other resistor. Now, trigger and threshold get tied together. So that is, I guess I could have went from yeah, I could have done that a different way. That was goofy of me. Let's see, do I have enough? I don't think I have enough lead left. No, I don't. Okay. So pin 2 goes to pin 6 because trigger and threshold are tied together. So technically, since the second resistor goes to trigger, and trigger and threshold are connected together, you can just jump her from 1 to 2. So yeah, let's do that instead. That'll make everything a little neater when we actually have to go to build it, because there's not going to be much space on this board to build it. All right. Fortunately, these little quarter watts are cheap. So 1 to 2. All right. So on 3 is control. We don't normally put anything on control, but in this case, we are going to put a capacitor just to help drag everybody to ground. Actually, let's use this little ceramic disc. So 3, 4. 4 is reset. Reset goes to the positive rail. And then, of course, 5 is our output. Now we also need a ground. Pin 7 is our ground. So we'll take that up to power, which is the ground pin of our 7805. Okay, and here's our output. So we will, let's see, just use an LED for now. Let's see, that's 47K. Excuse me. That's 5100. That's what, 5.1K. 1.3K. 3.3, 330. Let's see. And we'll take that back to positive rail. Let's see, let me make sure the LED is correct here. Okay, so 1. Okay, so we actually, I think, wanted to go this way. All right, so let's pull the chip out first. And I'm going to give it about 7 volts input. That's about the output of a lithium-ion battery pack. And we'll measure the voltage. On the output first. The output of the 78L05, that is. We want to make sure we have 5 volts. All right, let's see. So that's our input. This will be our ground. Actually, we can get a ground right off of the terminal. Volts, volts, volts. I need some volts. Let's see. Volts, auto range. Let's see. Oh, get in there. Okay, we got ground. Let's see, here's positive. We'll just pick up off of our LED since it should be hot. And let's get ground. Let's see what we got. 4.97 volts. Excellent. So we will, let's see. Yeah, let's shut this off. Let's put this back in. I think the last one I had output connected to control, and I blew the chip. All right. Well, I guess here's the moment of truth. Now let's make sure. So I'm leaving that on to 5 volts. 4.97. Oh, either I have that set up the wrong way, or let's see what we got here. We have 4 volts on the output. So at some point that should go low. No, I think I did have that incorrect. There we go. Yeah. Riding the short bus again. Sorry, kids. So I don't know if we'll be able to see that. Okay. We don't see anything. So, we should be able to more than sync that current. So let me just watch that here. There it goes. No, it's not turning on. What the heck? Three, three, oh, oh. So it should be a 330. Okay, well, maybe I'm a moron and I'm misreading that. So let's put this in Yield Tester. No, 330 ohms. Okay, so maybe it's just not capable of lighting this one. I mean, that is an old LED. No, there it goes. Why not? It must just not have been making good contact. All right, so let's turn this off. Now let's go to the other side. So for this side, I'm going to need a 22K and a 330 because I want a longer time delay. So this one will go from discharge to trigger. So this will go from what? Here to here. But then I need a 330. And I gotta find it in this mess of resistors here, which is gonna be fun. There's a 33 something or other. Let's see, there's a 39. Let's see, 33000. That looks like a 33K. I need one with, I need orange, orange, black, orange, not orange, orange, black, red. So, la 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 la. Buy big kits of parts, they said. It'll have everything you need in it, they said. Notice, however, they didn't say anything about it being easy to find. And it's not. Well, did I miss it? I guess I rely on them to fill all of the parts in here as well. Oh, they are marked, interestingly enough. Here we go. 330Ks. Of course, it's in the very, 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 very bottom. Because why wouldn't it be? And of course, these aren't going back in here at all like they came out. Because somebody laid them all in so nice and neat. Warning, not suitable for children under 6 years due to small parts. Of course not. Buy them a 5-watt resistor kit instead. Harder to swallow. Okay, so I have a 330. Of course, it's a 1/2 watt, not a 1/4 watt. And these are oddball 1/2 watts. They're very long bodied, which is kind of strange. But, you know, I guess you can't be choosy. You buy a kit, that's what you get. All right. Let's see. Well, I do not have hardly any spaces left for positive rail. Well. Okay, so it goes from VCC to discharge. And then discharge to trigger. The trigger and threshold get tied together. I'll have to put my positive filter on the other side. So let's see, that's no, that's this one here. That's the bottom one. Of course, then this goes to ground. 3 is the, or rather, that's not 3, that's the 3rd pin, that's control. So we'll take that to ground with a bypass. Reset is the next one, and that goes to the positive rail. Which I'm running out of, like I said, I'm running out of space here. And then, of course, the next one is the output. Okay, output. So I still need my positive filter here. All right, we'll just put that right here, and then we'll just run. No, we can't, can we? We'll just put that right here and run our filter back to ground. Maybe. All right. Kind of a crappy thing, but hey, whatever. So let's move this over to here because we're going to have to bring our positive rail over for our other LED. So I don't think I have any more 33s out. So 330, 47. So 510. 510 might work. I mean, it's not super critical here. And I don't want to use one of these Western Electric units. They're just the wrong kind. What do we have on here? That is 150. That's not really what we want either. All right, let me get another LED. Oh, LEDs, where do you bees in this mess of crap? Let's see. Here we go. Here's a Stanley yellow. All right, I've got a similar LED. Okay, so that good. Positive goes up. Another Stanley LED, except this one's yellow. All right, so I think yeah, we should. Okay, we go from positive rail to discharge, from discharge to trigger threshold. Threshold goes to trigger. Let's see, control goes to ground through a capacitor. Reset goes directly to positive rail. Here's our output. And of course, that's trigger. And we have our capacitor that goes from trigger to ground, which is from over there. All right. Stand by. All right, welcome back. To take care of a little business there. So let's see, here's our positive. Our ground, of course, yeah, there's my headset. Our grounds are all down here. And let's pick up our ground again. And let's pick up our positive rail up here. Let's see, 4.96. So let's see. So this one should flash first and then the yellow one. Why not? See, do I not have the right one there? No, I have 4 volts. Okay. Okay, no, it did. It's not disabling. Interesting. Nope, there it goes. Wow, that was way long. That was really long. I wonder why that was. Did I get a 4-second delay there? Maybe. Oh, I know why. Because I'm a moron. So I picked a 330K when I wanted a 270K. I don't know why I said 330. I looked right at it, saw 270, and picked 330. So let me find the correct values here. All part of experimentation. 820s, see 680s, and I'll get a 330 to put in line with that one. There's a 390, 75, 56, it's 82, 68. So yeah, the delay is a lot longer than it should be because DumDum made it a lot longer than it should be. There's a 47 ohm, 22, 510s, 2Ks. All right, let's put all these back in nice and neat this time. $180R. Let's see. A20s. 3R3. No. $680, 15, 27, 300. There's 300s. Need my ohm stretcher. Make those into 330s. If you don't have an ohms stretcher, really should get one. They're quite a miraculous little piece of technology. There we go, 330. That's what I want for this guy. So I just need to still find the 270s. For the other ones. That's the bad thing about these big packs of resistors. Like I said, they're great until you need to find one. And here we go, 270K. And this is a little better anyway. It's still not. These boxes are like maps. You open them once, you'll never fold it correct again. Let's turn off our volts. All right, this is the 270. Okay, it's you. Come out of there, Mr. 330K. We'll save you for something else. And we need a 330. That'll be for our LED. put you up here. Move you up here. All right, we should have a better rate this time. Okay, there's our red. Now our yellow should be shortly after. I hope. No, what the hell's going on here? Well, that just doesn't seem right, does it? Yeah, something's wrong there. I mean, that's like minutes almost. Come on, you piece of crap box. What's wrong here? And it's staying on far too long. So what's 220? That's because that's a 220. Boy, oh boy, oh boy, are you a friggin' moron or what? And I probably cut it right off of the 220 slab, didn't I? Not sure what I'm trying to do here tonight. All right, let me get a 22. Boy. Talk about being a goofball. I don't know what's going on here. All right, let's see. This really needs a toothpick to wrap it around. All right. Let's pull you out. Yep, 220K. Get off there. $22K. All right, let's try that one. Okay, there's our red. Our yellow, there's our yellow. There's our red. There's our yellow. All right, I think we've got what we want here. And you can see they're starting to get closer together. So I think what we have here is what we need. So after writing the short bust for the entire evening, we have things straightened around. Now they flash together. Awesome. So now I just have to figure out how to put all of this, not the LEDs, of course, but all of this little circuitry down here, plus 2 relays on a small little proto board. And I think the relays are probably going to have to end up being on wire leads because there's just no room. But we'll figure something out, so not a big deal. So thank you for joining me. This is Brian at Projects from the Bottom Drawer. You can find us at wearboard.com/projects or bottomdrawerprojects.com.